Welcome to my virtual scientific class, where today we will be analysing and discussing a topic that relates to the gases in our atmosphere, applying Charles's law, then testing the variables through worked equations will provide you with the understanding and knowledge of how a hot air balloon ascends into the sky. A hot air balloon is operated by a propane burner heating up gas which rises upwards and fills a balloon. As the balloon fills with air, it displaces the air around it, much like when an empty water bottle displaces the water around it when held underwater. If the displaced air inside the balloon is lighter than the air outside, it will begin to lift off the ground. According to the National Air and Space Museum 2012, when the air inside the hot air balloon is less dense than the air surrounding it, buoyancy occurs, an upward force that the air exerts. So the reason a hot air balloon rises into the air is because of the different density of gases which are separated by a container, the balloon itself. So where does this air come from? How does the balloon expand? Well, the propane burner does not actually create air which fills the balloon. It heats up already present air, causing its volume to increase, causing the balloon to expand. This can be proven by a scientific gas principle known as Charles's law. According to Chemistry 301, University of Texas, 2014, Charles's law states that the volume, V, of a gas is directly proportional to the temperature, T. This law is valid as long as the pressure and the amount of gases are constant. Charles' law is written as V1 over T1 equals V2 over T2, and for it to work, temperature must be measured in Kelvin. Now on to some worked examples. The air inside of the hot air balloon has a volume of 14 litres, while the propane torch is maintaining a temperature of 50 degrees Celsius. What will the volume be equal to if the propane torch is turned up to maintain a heat of 91 degrees Celsius? The first thing we must do to answer the question is to write down our known values. The V1 value, which is volume before the temperature change, is 14 litres. The T1 value is 50 degrees Celsius. Before we move on, we must convert this value from degrees Celsius to Kelvin. This is done by simply adding 273. Making our T1 value 323 Kelvin. The V2 value is unknown and needs to be found by plugging the other value into Charles's law formula. The T2 value is 91 degrees converted to Kelvin, which is 362 Kelvin. Now that we have all the values we need, we can plug them into the formula for Charles's law. Now that we have found the V2 value, we can plug it back into the equation to confirm that both values are proportional. We then convert both fractions to a decimal value, and the answer should be proportional. Now remember, Charles's law holds an assumption that the pressure is kept at a constant value. If the pressure changed, this equation would be incorrect. It was stated before that a hot air balloon floats due to the difference of air density inside and outside the balloon. So how can we prove that hot air is less dense than cold air? This can be done by simply relating the equation for density, which is density equals mass over volume, to what we have learnt about Charles's law. Charles's law states that the volume of gas in a hot air balloon increases as its temperature increases. Therefore, a certain mass divided by a higher volume will result in a lower density. The mass of the gas in the air balloon remains constant. This is because no new gases are entering the balloon. The gas is just expanding. We can relate this to the law of the conservation of mass. Matter is neither created nor destroyed. Now for a worked example. We can use our V1 and V2 values from the previous worked example, and we can say that the gas has a mass of about 10 grams. So the density before the air is heated is 0.71 grams per litre. And density after the air is heated is 0.64 grams per litre. Therefore, it is proven that as the volume of the gas increases, the density decreases. This is what causes the air balloon to rise into the air as it displaces the denser air around it. This virtual scientific class has covered Charles's gas law, which applies the real-world situation of the flight of a hot air balloon. An assumption we hold for this lesson is that all the worked examples were done with example gases and values. They were purely drawn out to explain how the law and equations function. I hope you've learnt lots from this video. Please remember to comment, like, and subscribe.